In this learning objective, we discuss the implications of modern portfolio theory for portfolio management. The key implication of modern portfolio theory for those managing a portfolio can be summed up in two words: diversification matters. So let's have a look at why diversification can benefit an investor. When we think about the risk of a portfolio, the risk is comprised of two elements: systematic risk and unsystematic risk. Systematic risk is exposure to market-wide factors, whereas unsystematic risk is the firm-specific risk. We know that through diversification, an investor can reduce the level of unsystematic risk within the portfolio. In simple terms, diversification matters because when you diversify, you eliminate this unsystematic risk, hence lowering the overall risk of a portfolio, yet diversification does not have an adverse effect on the returns of a portfolio because the returns of a portfolio are simply just the weighted average of its parts. If we explore further the impact of diversification on the risk of a portfolio, we can look at the slide that we see on the screen here. What this slide details is the average standard deviation of an equally weighted portfolio comprising N stocks, where N is any number from 1 through to 1,000. So what we can see is when we look at this graph is that on average, if we have a portfolio of one stock, we're going to see an average standard deviation of upwards of 50% per annum. As we diversify, as we add additional stocks, so we go from a one asset portfolio to a two asset portfolio, we can see that the average standard deviation of the portfolio decreases. And as we keep adding stocks, we can see that this level of risk, this overall standard deviation of the portfolio, continues to decrease. However, what's important here is that this decrease is not linear. That is, each additional stock that you add to your portfolio does not, on average, decrease risk by the same amount. When we get to approximately 12 stocks in our portfolio, we can see that this line starts to get quite flat. So there's still a marginal decrease, but even if we look here, the difference between 20 and 100 stocks in a portfolio, the decrease in the risk is relatively small. Now what this curve is doing, it is asymptoting toward the overall level of risk exposure in the market, or is asymptoting towards the level of systematic risk within our portfolio. The decrease in level of risk is a reduction in the unsystematic risk. Now we can also identify the benefits of diversification by reconsidering the calculations of risk and return for a portfolio. So imagine a really simple world where we've got two stocks, BHP and Foster's Group. We're investing 60% in BHP and 40% in Foster's, and the expected returns of the two securities are 11% and 7% respectively. Now what we know is every time we calculate the expected return on any portfolio, the formula is always the same. The formula is simply just the weighted average of the parts. Or in this case, we've got 60% in BHP multiplied by the expected return of BHP, 40% in Foster's Group multiplied by the expected return of Foster's Group, so an overall expected return on this portfolio of 9.4%. So the key takeaway of this is that diversification has no adverse effect on returns. Diversification simply means that the expected return of a portfolio is the weighted average of the parts of that portfolio. So what about risk? What happens with risk? Well, what we've got on the board here is the variance of a two-asset portfolio. We know that the variance of a two-asset portfolio is calculated as the weight of the first asset squared multiplied by the variance of the first asset, plus the weight of the second asset squared times the variance of the second asset, plus 2 times the product of the weights, the correlation between those two assets, and the product of the standard deviation of the two assets here. Now when we look at this formula, what we're thinking is, well, is there any benefits in diversification in terms of risk? And where we can see that these benefits arise is that we can identify that the risk of a two-asset portfolio is not simply just the weighted average of its parts like return is. In fact, the risk of a two-asset portfolio is less than the weighted average of its parts. We can think about it this way. If the variance of the portfolio were simply just the weighted average of the parts, then the formula would look like the following. So if the standard deviation of the portfolio was calculated in the same way as expected returns, we would just have the weight of the first asset times the standard deviation of the first asset, plus the weight of the second asset times the standard deviation of the second asset. So if that were the case, the variance of the portfolio, we would square both sides. And if we expand the brackets here, if variance of a portfolio were simply the weighted average of the parts, then the formula would look like this down the bottom. Now this is similar to the actual formula for the variance of a portfolio that we see here, but with one minor exception. The minor exception is that this formula does not include this correlation term. And this is quite important, because what we know about correlation is that it is measured on a scale between -1 and +1. So that means that by inserting that term, we're inserting some number into this equation, and we're inserting some product into this final term that is a value between -1 and +1. And what we know is that for any value of rho, except for 1, let's leave 1 to aside for now, but for any other potential value, multiplying, for example, by a negative number here will make this whole term go negative, so it will decrease variance. Multiplying by a positive value here that is less than 1 will still reduce this term, hence it will still reduce overall variance of the portfolio. Okay. The only exception is where correlation between the two assets is 1, where you've got two perfectly correlated assets. In that case, that term becomes 1, and the variance of a two-asset portfolio is simply just the weighted average of its parts. So there is no benefit to diversification where you've got two assets that are perfectly positively correlated. However, in every other instance, wherever the two assets are anything less than perfectly positively correlated, the variance of that two-asset portfolio will be less than the weighted average of the parts. So quite simply, this is very important. When we diversify assets, we end up with an expected return that is the weighted average of the parts, and we end up with a value of risk or a variance that is less than the weighted average of the parts. If we think about framing this in terms of a Sharpe ratio, remembering a Sharpe ratio, we've got expected returns on the numerator and risk on the denominator. Basically what we're doing is our numerator remains unchanged because the expected return is just the weighted average of the parts, whereas the denominator is something less than the weighted average of the parts, so diversification will increase our Sharpe ratio. Another key takeaway from this formula we see on the screen here is the importance of this rho term, or the importance of correlation. In fact, what we know is that the gains from diversification are closely related to the value of the correlation coefficient. That is, the lower the correlation, the greater the gains from diversification. So the closer this rho term is to -1, the more reduction we'll see in the overall variance of the portfolio. However, it is important to note that while a negative correlation between the two assets will result in additional reduction in risk, the two assets do not need to be negatively correlated for there to be benefits from diversification. We only need the two assets to have a correlation somewhat less than 1. So if we look at a matrix here, what we can see is that for the two assets that we looked at before, BHP and Foster's group, we can calculate the variance and the standard deviation of the portfolio, and we can see that that standard deviation is less than the weighted average of the parts. Hence, the Sharpe ratio of this portfolio would be greater than the Sharpe ratio of either of its components. Next thing to consider, this is a two-asset portfolio. What happens with risk when we move to additional assets within our portfolio? Well, when we go to a three-asset portfolio, what we start to see is the formula expands like the following, and we have 3 of these correlation terms here. And these correlation terms, we've got 2 times the correlation between 1 and 2. We've got 2 times the correlation between 1 and 3, and 2 times the correlation between 2 and 3. Correlation is starting to become a very important component of the overall variance of the portfolio. In fact, one way to think about this is here we've got 3 variance terms. So variance of asset 1, variance of asset 2, and variance of asset 3. But we've got 6 covariance or correlation terms because we've got 2 times this one, 2 times this one, and 2 times this one. So the variance of a 2-asset portfolio has 9 total terms, 3 of which are variance terms, which is the risk of the individual assets, and 6 of which are covariance terms, which is a measure of the co-movement between assets. This is relevant because as we continue to expand, as we go to a 5-asset portfolio, the formula for the variance of a 5-asset portfolio comprises 5 variance terms, but 20 of these covariance terms. So we see as the portfolio gets bigger and bigger, the formula for the variance of the portfolio becomes dominated by these covariance terms. That is, the covariance, or the co-movement between the two assets, becomes the most important determinant of the variance of the portfolio, and not the variance of each of the assets within that portfolio. That becomes a relatively small part of the calculations, these terms along the top here. So, diversification benefits are greater the more assets that we incorporate into a portfolio, because every time we incorporate a new asset, we're adding more and more covariance terms, hence we're able to reduce risk further and further. The key to the correlation, the key in terms of diversification of big portfolios is the correlation between each pair of assets, because as we've seen before, when we have a portfolio comprising n assets, then the formula for the variance of the portfolio will have n variance terms, and it will have n squared minus n covariance terms. So before, where we had a 5-asset portfolio, there were n equals 5 variance terms, and there were 25 minus 5, or 20 covariance terms, as we see here. If we expand further for a 50-asset portfolio, there would be 50 variance terms and 2,450 covariance terms, which really goes to show that in big portfolios, covariance terms dominate the calculation of portfolio risk. And we can actually generalize further. If we generalize out to an n-asset portfolio, so a really large portfolio, then we can actually use matrix algebra to show that the variance of an n-asset portfolio is the sum of the product of the weights and the covariances between the assets. Now this can reduce down, and we can say that assuming that we've got an equal weighted portfolio, and using historical values of covariance and variance as inputs into this equation here, this formula, mathematically, we can actually show that it becomes the variance of a portfolio is 1 over n times the variance of each of the assets within the portfolio, plus n minus 1 over n times the covariance between the assets in the portfolio. And if n's really big, this term effectively disappears, so the variance of the portfolio effectively becomes calculated as the average of the covariances between each of the assets. So covariance is the key determinant of the risk of a portfolio. Hence, the benefits from diversification are clearly linked with correlation. And the key takeaway is that from modern portfolio theory, that we should diversify, we should not simply hold single asset portfolios.